A very good morning, children. In this video, we are going to see a new concept which we can relate in our day-to-day life. It is just related with a small concept that's called heat, exchange of heat. What is this meaning? What is meant by the meaning of exchange of heat? Just one small example I'll take for you. Don't think I'm having this tea in a glass to drink even the class is going on. See, when we pour some hot tea or coffee in a glass, from the tea, that's the content, as it is already hot, it is giving heat to the glass, and we will find difficult to hold this glass when the tea is hot. So, from this entire room, I am not feeling hot actually. But from where am I feeling hot? I am feeling hot much when I hold this glass, because in this glass what is the content present? Some hot tea is present. So from this whole classroom, I am calling this classroom as a universe. Means the rest of the place from my case study. My case study is with the tea because it is related now with the loss of heat from it. That's our know. So this part of this room, the small part of this room, I am calling as the system. What am I calling this one as the system? So we are not calling the system as the computer or something. System is the part of the universe, where you are studying the heat change. So this part of the universe, only the smart part of the universe, where you are able to study the change in heat, you call it as the system. And the surrounding, means this glass and the remaining section, we call as the universe. Means universe is the remaining part of the system. Universe is the remaining part of the system. That is around, universe is the remaining part of the system that is not under observation. I hope you understood the concept, children, a little now. What is a system, children? System is the part of universe that is under study. Don't think I am getting sweat only due to this cup of tea. Here surroundings are very hot in climatic conditions. So what is the system? Very simple point. Whenever there is a change in the heat content in and around us, see, I am feeling so much hot due to the temperature change in temperature. Means it is also a thermodynamics. It is also the part of called thermo, means heat change. Study in the heat change we call as the thermodynamics. So these two words are very clear for you now: system and the surroundings. Now imagination, the tea glass once again I am laying in front of you here. If at all, we are imagining there is some container, tea container. When your mother is preparing this tea, what I observe my mom when she is preparing the tea is when the tea is boiling, some of the vapors are being formed. From where do the vapors will be formed? From the water present in this milk, is it not? So the vapors that are released out means some of the content from the system is escaping into the surroundings. Some of the content from the system is escaping into the surroundings, is it not? Now we are saying until and unless our mother places a lid over this one, the content will escape into the surroundings, right? So what is the system is able to do now? It is able to exchange the heat to the surroundings as well as some of its content into the surroundings. Such kind of system we call as an open system. What type of system we call as an open system? Open systems can exchange both heat and also matter to the surroundings. Now, if I place some lid over this hot container, then matter will not be exchanged. What will not be exchanged, children? Matter will not be exchanged. Means water vapor will not be exchanged, but only heat will be exchanged. Such type of systems we call as the closed systems. What type of systems we call as the closed systems? Means what is a closed system? A closed system can exchange heat but not the matter with its surroundings. What are surroundings? The remaining part of the universe. And that's not an observation is called as the surroundings. Now, if you take a thermoflask, if we pour the tea into this thermoflask, up to 8 to 10 hours, your tea will be hot in condition, either tea or hot milk or coffee, whatever it may be, SR. After pouring tea into the glass, what I felt is the glass is little heat in condition. You observe. But when I am holding this thermoflask, I don't feel the heat is absorbed into the body, because this container what is there, it is not giving out heat from the tea to the surroundings, as well as it is already closed, it is not exchanging matter to the surroundings. So this kind of systems which cannot exchange either heat or matter to the surroundings were said to be isolated systems. What are they? Isolated systems. These are the three main definitions, simple definitions. One is called as a closed system. Starting we went with open system, which can exchange energy as well as matter. The second thing, which can exchange only energy but not matter, closed system. What is an isolated system? Which cannot either exchange matter or heat to the energy to the surroundings. It is called as an isolated system. These three are called as the types of systems. And we have two other terminologies. The two other terminologies are called as the state of the system. For example, how can you convert a liquid substance into gaseous substance, children? Can you could say how many methods you can apply? Yes, I can take a gas stove. On that I can pour the water in a vessel and I can go on boiling that. So by absorbing the heat from the surroundings, our system will exchange from liquid state to solid state. Is it not? Means there is a change in temperature. What did you observe? Change in temperature. That can be achieved in any of the method. And here there can be in different phases. What I say, a system is said to be in a given state. When the thermodynamic variables means the variables that depends upon the heat content. What are the variables that depends on the heat content? Means either pressure or volume or temperature, and composition have a fixed value. Means the state of the system you can say when these are in a fixed value. What are they in a fixed value? Pressure, volume, temperature or composition. When they have a fixed value, then only you can identify the state of the system. And there is one more definition. It is called as the state function. Means function and organs we know generally eyes, ears, nose and everything. They have a specific work to do. Here, generally states of matter means solid, liquid or gas. We know. You are trying to convert a liquid to gas, already introduced for you. Now, if you want to convert a liquid to gas, you can do it many methods. That's what the topic actually introduced for you. You can use a stove, or you can use an induction stove, or you can place it under sunlight and place one mirror, zooming mirror, so the content can be heated up. So it does not depend how you heat the system, but it's depending upon whether you had heated the system or not. That's called as the state function. Once I'm reading the definition, a function which depends upon only on initial state and final state. Let us say we had started boiling a milk. It does not depend how you boil. It depends upon what is the starting energy and what is the ending energy of the system. That's what it is saying. A function which depends upon only initial states and final states, but not on the path. Means how you observed, how you had heated does not depend. It depends upon initial energy and the final energy. That gives the total internal energy of the system. Here, the energy may be in different forms. It may be like internal energy. What is meant by internal energy? See, the energy possessed by a system. The energy possessed by a system is called as its internal energy. It may be either kinetic energy, potential energy, rotational energy, vibration energy. Different forms of energies are there. We will see them later. Or you may bring a change in the state of a system either by bringing a change in the heat content. That's a delta H value, change in the heat content, enthalpy change, we call as the enthalpy change, or disorderness. Solids are generally fixed, liquids are movable, gases can easily move from one place to another. Means gases have more disorderness. So the measurement of this disorderness is observed using a entropy value. What is it we call as the entropy value? So any of these can decide the state function. Which of these can decide the state function? Either internal energy, enthalpy, or entropy can decide the state function. But we forgot to read these definitions now. So once again, read these definitions. You can write down what is thermodynamics. The study of interconversion of heat and other kinds of energy. The study of interconversion of heat and other kinds of energy is called as thermodynamics. And what are the fundamental concepts in this thermodynamics means? System. A part of the universe under study, like our T in the container. Surroundings, the remaining part of the universe that can interact with the surroundings. Even our system, like our T, got perfect boundary, but sometimes it's not necessary. The systems must have a perfect boundary. You are doing many reactions in test tubes. The content present in the test tube is called your system, and the remaining part of the test tube is called as the sun. Or you can see the types of systems. Open system can exchange both matter and energy to the surroundings. But what is a closed system? Can exchange only energy but not matter. What is an isolated system? Cannot exchange either matter or surrounding, matter or energy to the surroundings. Write on these points, children. Yeah, right. We were introduced with the word internal energy. We are taking a few explanations regarding this word internal energy. Generally, we know any body possesses two kinds of energy, potential energy and the kinetic energy. So the sum of these two kinds of energies, the kinetic energy possessed by the body and the potential energy possessed by the body, will give the internal energy. There are some symbols that we are going to use in this chapter, children. The internal energy is used with a symbol called capital U. Capital U. What is internal energy? It is the sum of total kinetic energy and potential energy possessed by the system. These internal energies, it is not a single value. It depends upon different other sub-values. For example, a whole body means it is the sum of hands, legs, head and the body. Is it not? Similarly, the internal energy is depending upon different forms of energy, because the gaseous state of matter will move from one man to another place. It's called translational energy. The energy possessed by the moving gas particle we call as translational internal energy. Solids does not move from one place to another. They vibrate at their mean position. They possess the vibrational energy. And we have the electrons that are revolving around the protons. The electronic energy within the atom we got. So these are different kinds of internal energies are there. This sum, what we are calling for the definition for internal energy is total amount of kinetic energy and potential energy possessed by the system. Possessed by the system is called as internal energy. It is denoted by the symbol capital U. Made up of different forms of energies. What are the different forms of energies that are related for this internal energy means? One is called as the rotational energy. The particles will be rotated from one place to another. Or translational energy, or we can speak vibrational energy. See, these are all internal energy only. So rotational energy suffixed with R to the U. Translational energy suffixed T to the U. Vibrational energy suffixed V to the U. And electronic energy where E is suffixed to the U. Nuclear energy, N is suffixed to the U. And gravitational energy, G is suffixed to the U. Some of these all energies will give the internal energy of the system. They are equal to the internal energy of the system. So is this internal energy is a state function. What is state function? For example, you have taken some liquid, you went on heating it. In the starting stage, the water is having hardly 25 degrees Celsius. You imagine it is at the liquid state, room temperature. When you have heated up to 100 degrees Celsius, now it is changed in the gaseous state. Now it depends upon only the final stage and the initial stage. The internal energy is now depending upon only the final stage. Initially, how much energy is there? 25 degrees Celsius we mentioned. Finally, how much energy is there? Heat content is having 100 degrees Celsius, which is more. 100 degrees Celsius more. So what we said, there is some change in internal energy which depends upon the state function of the system. Generally, state functions are independent on the path they were achieved. So what we are doing is the internal energy is a state function. Internal energy is a state function. It depends upon only state of the system, but does not depend on it is achieved. So the change in internal energy is represented as the delta U. Delta U. It is equal to energy, internal energy at the final and internal energy of the minus internal energy of the initial stage of the system. At times we can also represent change in internal energy given as U2 minus U1. U1 is the initial internal energy of the system. U2 is the final internal energy of the system. But this depends upon three main factors. How does the internal energy will change? Means three factors are playing. If there is a heat content change, means heat is given into the system or heat is taken out of the system. When work is done on the system or work is done by the system, or we can speak when matter enters into the system and matter leaves to the system. Based on these conditions, the internal energy depends upon. What are they? Based upon heat pass in or out of the system, work is done on or by the system, matter enters or leaves the system. Here a small point I will give for you children, keep in mind. If you are getting 1 crore rupee, you are being added by the sum, this is not. But due to some scam, you lost 1 crore rupee. You lost the money. Whenever you are gaining the money that is coming into you, when you are losing, your money is being lost. Is it not a small shortcut algebra? How to remember these terms? Internal energy depends upon what? It depends upon the change in the heat pass in out of the system. When heat the term you get, you are going to use a symbol for heat that's called Q. When heat enters in to the system, means system is gaining the heat, then you will have a plus Q value. What you will have a plus Q value. But it is leaving out of the system. Which is leaving out of the system? It is leaving out of the system. Then you will have a minus Q symbol. Minus Q symbol. What is Q? Q is the heat representation here. When the work is done on the system, when some work is done on the system, we will represent the plus Q. When work is done by the system, some work is lost by the system, WQ. These are the two very simple things. On the system means when system is getting the heat into it, positive. When system is losing the heat from it, negative. When work is done on the system, positive. When work is done by the system, negative, W. These are the very important terms you need to keep in mind. Just note down the points, children. With this small definition for today's video, I will conclude, children. Adiabatic process means what? Last word we were ended with one word, no? Internal energy is depending upon when heat is entering in or leaving the system. For example, heat is not entering or heat is not leaving the system, but there is a change in temperature. What is it, children? There is a change in temperature. There is a change in temperature, but there is no exchange of heat in or out of the system. Means the Q, there is no change in heat. Delta is the symbol that will bring for change in the either heat or enthalpy or entropy. Delta is means the difference between final stage and initial stage. When there is no change in the heat content, when the delta Q is not changing, means there is becoming to 0, but there is a change in temperature. Means delta T is not equal to 0. At those cases, we call the process as the adiabatic process. Generally, the concept is very useful for the objective purpose. They will introduce in the question during an adiabatic process. They will start the question like, and now we need to keep in mind what is an adiabatic process. There is no change in the heat content. Q becomes 0, but delta T means change in temperature is not equal to 0. For this video, we are entering here, and the next day we will see what is the first law of the thermodynamics and the remaining concepts. Have a nice day, children. Thank you.